That's x times x plus 1. As I said, I'm hopeful that if I give you one that requires partial fractions in a real casual way like this, that you will just be able to kind of play around with the constants and see what works. But if I put 1s on top here, what happens when I subtract those two fractions? What do I get? The integral. So if you don't have the confidence to take something like this and just play with the constants until it works, then you have to go through the whole partial fraction decomposition process. All right, so I'm going to run out of room, so let's just go ahead. I think we'll find that this problem is a little easier than the last one we just attempted. So this is equal to the limit as t approaches infinity, integral from 1 to t of 1 over x minus 1 over x minus 1 dx. And that's what I have. Can't you see that from where you are? This is equal to the limit as t approaches infinity of ln absolute value x minus ln absolute value x plus 1, only value weighted 1 to t. And this is the limit as t goes to infinity of the ln of x over x plus 1, and I don't need the absolute values because we're going from 1 to t, and t is going to positive infinity, so everything's positive there. Well, this is the ln of the limit as t goes to infinity of x over x plus 1. Oh, as x is evaluated from 1 to t. Is that cool? And this is the ln of the limit as t goes to infinity of t over t plus 1 minus 1/2. I don't even need L'Hopital's rule. The degree of the top is equal to the degree of the bottom. I know I'm going to take the ratio of the leading coefficients, 1 over 1. So this is equal to the ln of 1 minus 1/2, which is the ln of 1/2. There, you happy? You got your problem. Well, 1 minus 1/2 is 1/2. Huh?
It's okay. What's the reason why you took out the ln from, like, you put the ln on the left side?
Because I thought that was easier than this.
It's the same thing.
Well, remember that we can exchange the order of a limit with a continuous function from way back in chapter, like, 2 or something.
Okay.
I said that. And that was the genesis of what allowed us to do logarithmic differentiation on the last test.
Right.
Remember, we took ln's of both sides when we were doing the limits, and the ln just went inside the limit. That's the same thing I just did there.
Mm-hmm.
So if you want to get the answer in the book, I imagine they have ln 2 to the negative 1, which is minus ln 2. Same thing. So Monty wanted an example